Katie Early. Welcome to Part 1 of the Number Sense module, grades TK through 2. You will be hearing my voice and that of my three colleagues, Danielle Reynolds, Brian Lindeman, and Michelle Sanchez. We are excited to share this part of the module with you and hope you find it beneficial to the students you serve. Here are the topics we will be discussing in Part 1 of the module. How do children learn to count? Please take 1 minute to jot down your thoughts. We will next be watching a 7.5-minute video that focuses on how our very youngest students begin to understand counting and cardinality. As you watch, please note important points such as the following. What is subitizing? How does subitizing enable counting? What do we mean by one-to-one correspondence? How does this relate to cardinality? What else catches your attention? What new perspectives, what important messages do you discover? After watching the video, we will share some of the interesting aspects of how students grow as counters.
Before we ever get to addition and subtraction, and long before we tackle fractions and decimals, there's so much understanding that needs to take place. So here I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one-to-one is called subitizing. Some say sub, some say su. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these two hands, for example. If we were to put some candy in each hand, and then we were to ask a student, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count. So when students come to us in kindergarten, we now know that they have this idea of subitizing and more or less that they've been working on. So from there, we introduce rote counting. Rote counting, well, it's kind of like this. As students are learning the alphabet, they might say LMNOP and have no idea that there's actually letters embedded in there. Rote counting, same thing. Students are just working on that count sequence, the reciting of names. So an example of that would be as if we asked a student to count from 1 to 6. They might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said stop at 6. But you know what? They can't. They have no idea where 6 is in that count sequence. Well, in kindergarten, students should be working on that count sequence from 0 to 100, forwards and backwards. I think most students in kindergarten have had exposure to a hundreds chart or a 99 chart. But what about this one on the right? When the value increases, the numbers on the chart rise up. Now when we count up from 0, we don't go down, we actually go up. That might make more sense to kids. Something to think about. So as students are working on this idea of rote counting, we begin to introduce this idea of one-to-one correspondence. And to be honest, one-to-one correspondence, it's much more than simply tagging numbers to objects. Here's an example. If we ask a student to count 8 and place them in the bowl from a set, and they're able to do that, they're a producer of counting. They're able to do that one-to-one tagging to 8. Now, if you ask them how many were in the bowl, they don't know. They'd have to go back and recount them all over. A student that we'd ask how many didn't make it inside the bowl, well, they're a counter. They can count a finite set of a quantity. So for instance, there was 4 that couldn't make it. So we want to make sure that students are both counters and producers. And one way we can do that is by building this understanding of tagging, but not always with numbers. So here we have 6 bears, and we want to match each bear to a green present. This idea that's happening in one-to-one correspondence, it's really, really big, and we need to make sure that we devote enough time for our students to develop this understanding. So as students are working on rote counting and one-to-one correspondence, cardinality gradually makes its way into the conversation. What cardinality is when students are counting out a set of objects. The last number in that count sequence describes the quantity in the set. Students might count this pattern here of these pennies, but they might double count some. So now they use a counting strategy where they line them up and count from 1 to 8, and they know that they said 8 last, so that there's 8 in the count sequence. This was an example of a counter with the pennies, and on the bottom here with the rec and rec, we have a producer of 8. And they're able to tell you that it's 8 because of the last number. We then move on to hierarchical inclusion. Yeah, it's a really big word, but all that it means is that students understand that numbers are nested inside other numbers. So if we take that penny, for example, students would know that if you had 8 pennies, you must have 7 pennies. That numbers are nested inside the numbers. So if we ask students to put 7 inside this circle, do they need to count out 7 pennies, or do they just remove 1 and drag the set into the circle? The same idea with the rec and rec. Do students count out 7, or do they just know to remove 1 because 7 is nested within the 8? And at the final part of this progression of early numbering counting comes number conservation. The big idea here is that students understand that there's a decomposition of number. We might ask, are they the same? Students would say, yeah, we have the same number. But if we stretch out the blue row and ask which one has more, students might say the blue. This is at the heart of number conservation. It's about decomposition, that numbers can be broken apart, and that numbers, the whole, is made up from parts. So at the beginning, we talked about a perceptual subbatizer. Well, here we have 3 sets of 4. Well, when students get to this piece in the number sense trajectory, they understand that 4 is made up from parts. So now when we show students these dots and we show them these yellow cards, they're able to see that 4 just isn't a name, it describes the parts of a whole. Now we're getting to that conceptual subbatizing. There's a whole lot happening here. One thing to remember, the turtle won the race. Thanks for watching.
There are so many ideas and images in the video, it is worth watching more than once, and perhaps discussing with a colleague. A few points you may wish to consider include: why is it important for students to use physical objects as they develop understanding of counting and cardinality? What distinguishes perceptual subbatizing from conceptual subbatizing? Kindergarteners work on rote counting. Why do they practice counting backwards as well as forwards? What thoughts do you have regarding the inverted 0 through 99 number chart? As students work on one-to-one correspondence, over time they develop as both counters and as producers of numbers. Cardinality includes hierarchical inclusion. For example, within a set of 8, we can also find a set of 6. The idea of conservation means students recognize what is being counted. A group of objects that is spread apart may have fewer than a compact arrangement of objects. Kindergarten students work on decomposing numbers, understanding that 4 is equal to 1 plus 3, 4 is equal to 2 plus 2, and 4 is equal to 3 plus 1. Let's look at how the major focus areas for number sense progress in the continuum for students in grades TK through 2. These young students learn to organize and count with numbers, as detailed in the video. This enables children to describe their world numerically, a great power indeed. They compare and order numbers on a number path or number line. Students in grades TK through 2 operate with numbers flexibly, making sense of the operations as they explore addition and subtraction situations, often shifting between visual, numerical, and physical models. We will discuss the progression of number sense through the remaining grade bands in other parts of the number sense module.
How do students in grades TK to 2 organize and count numbers? Establishing this foundational understanding is a large part of the work in these grades. Starting in transitional kindergarten, students recite 1 to 10. They touch and name objects, which is essential for TK students as they count in order to connect the physical objects with a mental construct. With ample experience and opportunity to make sense of this mathematics, students develop the understanding that the last object counted represents the total number of objects in a group. Experiences that engage students in tactile and verbal counting support the acquisition of subitizing, which is the ability to recognize small quantities without counting. In grades 1 and 2, students focus on place value, understanding, and grouping of quantities. The key idea of place value prepares young students so they eventually will be able to handle any number of digits with understanding. Students strategically compose and decompose quantities in order to add and subtract. Dot pictures are an engaging means of practicing counting and developing the ability to subitize. A dot image is projected briefly. Children then count the number of dots and report the total found. The image is projected again, and the class verifies the result and discusses the various strategies they use to count the dots. Teachers can create dot images for their students or may find examples online, such as Splat, found at Steve Wyberny's blog, which offers multiple examples for all grades TK through 5. On the next slide, we will engage in a dot picture exercise. Prepare to view the image in a moment with the goal of quickly assessing the total number of dots. Are you ready? How many dots are in the image? How many dots did you see in the image? Think about how you counted them. What groupings did you use to count the dots quickly? Let's go back to this image and see how many ways we can count the dots. We can now see there are 8 dots in the image, but how did you count them? What groupings did you use to count the dots quickly? Can you find another way to use groupings to count the dots, and then another? For each grouping or counting strategy, what number sentence can we apply, or equation, that would represent the thinking? 5 plus 3? 3 plus 3 plus 2? 2 times 3 plus 2? 2 plus 2 plus 2 plus 1 plus 1? 5 plus 1 plus 1 plus 1? Here, we're trying to visualize 3 times 3 minus 1. I wonder if there's more. Integrating literature with mathematics is a means of engaging students to connect ideas across academic areas. With this book and activity, kindergarten or first grade students count and organize numbers, exploring combinations to make 10. Read through the description of the activity. See the link we have for you in the description below, and you may want to follow the link to a read aloud of the mouse count.
TK and K students benefit from games and activities that encourage the use of positional vocabulary, behind, above, next to, and comparisons, more, less, fewer, the same as. They rely on tactile materials, such as blocks, beads, pebbles, popsicle sticks, as they build connections between physical objects they count and develop a more abstract concept of quantity. Transitional kindergarten. Understand relational terms in the context of games and activities. Compare quantities of counters, blocks, or other small objects. Kindergarten. Build, count, and compare small collections of objects. Add on to sets of objects. In grades 1 and 2, the notions that 10 single units form a value of 10 and that 10 tens create 100 establish the foundation for place value understanding for young children. These concepts are significant milestones that demand abstract reasoning and deserve considerable attention for TK-2 students. Grade 1. Develop concept of a 10. Understand digits place value for tens and ones. Order quantities along number paths. Grade 2. Extend place value understanding to 3-digit numbers. Decompose numbers by place value to compare and arrange them on a number line. Young children are familiar with linear or curvy pathways. They walk along pathways at school or in the park. They move markers along paths in games such as hopscotch, Candyland, Chutes and Ladders, counting the spaces they land on as they move along the path. TK, K, and grade 1 students use number paths to compare and order numbers on a line. Number paths correspond to counting experiences for the youngest students. They are countable, familiar, and set a foundation for understanding of number lines, which are conceptually more abstract. Number paths allow students to order numbers by placing a number in each of the blocks provided. Number lines are more demanding conceptually, as the location of a number on the line represents its measurable distance from 0. For these reasons, the transition from number paths to number lines needs to be thoughtfully initiated. Grade 2 students use number lines to compare and order numbers and to solve addition and subtraction problems.
Students in grades TK through 2 operate with numbers flexibly. In transitional kindergarten, students act out story situations, add using fingers or small objects, combine quantities, count and recount to determine totals. Kindergartners develop meaning of operations of addition and subtraction, act out story problems, invent and explain strategies. Grade 1 students develop and use efficient, accurate methods to solve problems within 100, use manipulatives to model problems, understand properties of the operations of addition and subtraction. Grade 2 students use concrete models, drawings, and number lines, connect these to written methods to solve problems within 1000, explain why these strategies and methods work. Number talks are an effective means of supporting students' ability to order and compare numbers and to operate with numbers flexibly. Number talks engage students in solving problems using strategies that make sense to them. In number talks, students own the mathematics. They determine the correct solution, justify thinking, and critique the methods used. This diversity of mathematical thinking enriches the classroom community and invites students to implement the mathematical practices. Number talks provide insights into students' understanding and can reveal any underlying misconceptions. As they solve problems mentally, kindergarten children count to answer how many, and they decompose numbers. First graders understand and apply properties of operations and understand equality. Second grade students demonstrate understanding of place value for 3-digit numbers, and they use and explain estimation strategies. Solve these problems mentally yourself and note what strategic thinking makes each one possible and worthwhile for a young student to solve without paper or pencil. When students solve problems mentally and explain their strategies, they reveal the depth of their understanding of place value, operations, and the properties of operations. Teachers use these insights to plan subsequent number talks crafted to increase their students' ability to operate with numbers flexibly.
So we've just spent some time thinking about the mathematics in the framework, particularly the number sense chapter. In addition to mathematics, we also want to consider how we are integrating social-emotional learning principles into our mathematics instruction. Consider the question above and jot down a few of your thoughts. Self-awareness, social awareness, and relationship skills are some of the areas that can be developed in students as they engage in mathematics. Some students may need more support and encouragement to discuss their thinking publicly. However, with continued intentional experiences integrated into our learning environments, students will continue to increase their social-emotional competencies and therefore increase their sense of agency. Let's dig a little deeper into the big ideas of social-emotional learning and some specific connections to number sense. The Collaborative for Academic and Social-Emotional Learning, or CASEL, has identified 5 core competencies of social-emotional learning. Those competencies include self-awareness, self-management, social awareness, relationship skills, and responsible decision-making. Supporting students' social and emotional development does not need to happen in isolation or as a separate set of lessons. It is possible to integrate skill instruction and practices that supports SEL development within the context of your academic curriculum. Let's dig a little deeper into what that might look like for each of the 5 SEL core competencies. Self-awareness is the ability to understand one's own emotions, thoughts, and values, and how those impact how you behave. When participating in number talks, we are supporting the development of self-awareness by helping students learn to identify their feelings about the mathematics task and solving problems using multiple strategies, identify individual strengths and challenges, link their feelings, thoughts, and values to the mathematics and in participating in classroom discussions, experience feelings that they can do math, have a growth mindset, and develop an interest and sense of purpose with using different strategies and approaches. Self-management is the ability to manage one's emotions, thoughts, and behaviors effectively in different situations and to achieve goals and aspirations. When participating in number talks, we are supporting the development of self-management by providing opportunities for students to learn how to understand how they are feeling and choosing strategies to manage their emotions, identify and use strategies to manage stress, set personal goals and monitor progress in achieving them, use planning and organizational skills, and show the courage in sharing their thinking with others. Social awareness is the ability to understand the perspective of others and empathize with them, including those from diverse backgrounds, cultures, and contexts. When participating in number talks, we are providing opportunities for students to develop their social awareness by understanding the ideas and viewpoints of others, recognizing the strengths in others, demonstrating empathy and compassion, showing concern for how others are feeling, and understanding and expressing gratitude. Relationship skills are the abilities to establish and maintain healthy and supportive relationships and to effectively navigate settings with diverse individuals and groups. When participating in number talks, we are providing opportunities for students to develop their relationship skills by working and cooperating with others, actively listening to others' ideas and asking clarifying questions, communicating effectively with their classmates and teacher, developing positive relationships with others, resolving conflicts constructively, and seeking or offering help to their peers when needed. Responsible decision-making is the ability to make caring and constructive choices about personal behavior and social interactions across a variety of situations. Number talks support the development of responsible decision-making by allowing students the opportunity to demonstrate curiosity and open-mindedness, identify multiple solutions to problems, learn how to use information to make decisions or choose appropriate strategies, anticipate the consequences of one's actions, and be a positive and productive member of the classroom. These are just some of the ways the SEL competencies can be developed while we are supporting our students' mathematical agency. We know you will have other ideas to extend those lists as you integrate SEL into your math instruction.